Section 5.1, Probability Rules. By the end of this section, you're going to apply the rules of probability, compute and interpret probabilities using the empirical method, compute and interpret probabilities using the classical method, and recognize and interpret subjective probabilities. Now, do you recall the statistical process? Step 1 was to identify the research objective. Step 2 was to collect the data needed to answer the questions posed in Step 1. Step 3 was describe the data, and Step 4 was perform inference. Now, we've covered Steps 1 and 2 in Chapter 1. Step 3 was covered in Chapters 2 through 4. In the next 3 chapters, we take a break from the statistical process. Why? Well, recall in Chapter 1, we mentioned that inferential statistics uses methods that generalize results obtained from a sample to the population of interest and measures their reliability. How can we measure the reliability? Well, it turns out that the methods used to generalize result from a sample to a population are based on probability and probability models. Probability forms the basis for inferential statistics because it is used to measure the likelihood of observing certain outcomes. So you can see here that if an event has a highly likelihood of occurring, then it has a high probability, which is going to be close to 1. Now, if an event has a low likelihood of occurring, then it has a low probability, which would be close to 0. Okay, now for example, it is unlikely that we would roll 5 straight 6s when rolling a single die. So this result has a low probability. In fact, the probability is 0.0001286. If we were playing a game in which a player threw 5 6s in a row with a single die, we would consider the player to be extremely lucky or a cheater because it is such an unusual event, assuming the die is fair. Statisticians use probability in the same way. If something occurs that has a low probability, we investigate to find out what's up. Objective 1. Okay, understand random processes and the law of large numbers. Okay, so the word random suggests an unpredictable result or outcome. Predicting outcomes while facing uncertainty is rather challenging. For example, it would be difficult to predict whether the outcome of flipping a fair coin would be heads or tails from one flip. However, if we flip a coin many times, we may be able to determine the long-run proportion of times a head is observed. The process of flipping a coin many times is called a simulation. Simulation is a technique used to recreate a random event. Simulations can be tactile, as in physically flipping a coin, or virtual, using a computer to pretend it's flipping a coin. In both instances, the goal of the simulation is to measure how often a certain outcome is observed, such as a head in flipping coins. Now, to see this idea, we're going to simulate flipping a coin using a statistical applet. Okay, so I'm going to open up this applet. Okay, so in this applet, we can see that the vertical axis is going to represent the proportion of times we observe a head. And the horizontal axis down here is going to represent the number of coins that we flip. So in the applet, if I click one run, that's going to represent one coin flip. And as you can see, we're going to go ahead and flip that one coin. So what we can see here is that we get a head. So I click it and I observe one head. Okay, now that means that I have 1 out of 1 head that I have created here from our simulation. Now I'm going to click run again, the 1 run. And again, this time it gives me 1 number of heads. So now what I have is the proportion of the times I observe a head is now 2 out of 2. So we can see here the count is 2 out of 2, which gives me 1. Okay, so what we can see here is you can see in the Cartesian plane that we're keeping a running total of the proportion of times we observe a head. So if I click 5 runs, that's going to be 5 coin flips. Okay, so by clicking those 5 coin flips, you can see that now it gives me 5 heads out of 7 total. Let's do that again. Let's do 5 runs again. So 5 runs now tells us that we have 9 out of 12 heads. Okay, and so now you can see we're continually keeping track of the proportions of heads in the Cartesian plane. So now if I click 1,000 runs, that would be like me flipping a coin 1,000 different times in a random process. Okay, now what you should notice is that the proportion of times we observe a head settles down to a specific value. In this case, it settles down to 0.499 because 505 out of 1,012 flips of the coin resulted in heads. Now, if I hit reset, I can do the same thing a second time. So I'm going to go ahead and hit reset. Now, if my first flip, I observe a tail. Now I'm going to have a second flip, and I observe another tail. So that tells me I have 0 out of 2. The proportion is 0 out of 2. Now, let's see what happens on my next run. Okay, I get a head. So now I have 1 out of 3. So now I have the portion of 1 out of 3. And now I'm going to go ahead and click 1,000 runs. Okay, now you can see 491 out of 1,003. Let's click another 1,000 runs. Now we can see the proportion is 0.953. Let's do another 1,000 runs. And you can see again we have 1,482 out of 3,003, and it gives us a proportion of 0.94935. Okay, now you can see the proportion of heads again starts to settle down to a specific quantity. In this case, you can see that the proportion of heads is approaching 0.5. So a random process represents scenarios where the outcome of any trial of an experiment is unknown, such as we don't know ahead of time whether we're going to observe a head or a tail when we flip a coin. But the proportion or relative frequency a particular outcome is observed approaches a specific value. So if we go back to our coin flip and applet, you can see in the short run, in other words, for a few flips of the coin, we have a lot of variability in the proportion of heads observed. But in the long run, the proportion of heads settles down to a specific value. In this case, it's approaching 0.5. Okay, so now we're talking about a definition. So we need to talk about the definition of a random process. A random process represents scenarios where the outcome of any particular trial of an experiment is unknown, but the proportion or relative frequency a particular outcome is observed approaches a specific value. Okay, now what you just watched illustrates a basic premise of probability. Probability is the measure of the likelihood of a random phenomenon or chance behavior occurring. It deals with experiments that yield random short-term results or outcomes yet reveal long-term predictability. The long-term proportion in which a certain outcome is observed is the probability of that outcome. So we say that the probability of observing a head is 1 out of 2, or 50%, or 0.5, because as we flip the coin more times, the proportion of heads tends to approach 0.5. This phenomenon is referred to as the law of large numbers.